Machine, pencil, cartography. This channel's goals involve teaching my audience about navigational concepts in diverse settings. No person could proudly proclaim that they are a dignified or bona fide sailor unless they were also knowledgeable about pervasive topics which pertain to the ocean. For this reason, we must perform geographical examinations of the ocean, and we would need to know everything that there is to know about this topic. However, instead of beginning by saying there are 7 seas, we will instead begin by examining what the general composition of an ocean environment might look like. It will also be important to note that sailors will primarily interact with the surface of the ocean. Therefore, we may be more interested in the attitudes of the ocean's surface than we are about any event which might occur miles below on the sea floor. For sailors, the waves will be specifically relevant, and therefore we will examine interactions between waves and boats. So, to begin, we will examine how the boat behaves on calm water. The boat needs to have ordinary balance, and the boat must have even keel. The phrase even keel means that the boat will not fall onto its side upon making contact with the water. The topic of having boats that balance is actually an orthotics topic, and could also involve having boats with stability, which is also subtly an orthotics-related topic. At any rate, we may examine this problem mereotopologically, and an oceanographer or a bathymetrist is actually the most knowledgeable person available to discuss the behaviors of ocean waves. At the end of our exercise, the bathymetrist will produce a report on the ocean waves, and then the marine navigator will consume this report. The marine navigator will apply this insight in order to direct their navigational decisions. Now, we may imagine various wave topographies and ergonomics. To begin with, any wave that moves horizontally is called an advection, and any wave that moves down or up is called a subvection or a convection accordingly. For any given advection, we may assume that we may examine common characteristics of line waves, which include the wave length, designated by lambda, as well as the wave speed and direction. In the regions with active subvection, we will find active swells. Swells are low-pressure systems and have notoriously still waters, which promote smooth and tranquil sailing with almost no waves whatsoever. However, subvection areas are also areas where whirlpools may occur, as the low-pressure system is an area where riptides and whirlpools are likely to occur. Just for fun, oceanographers also like to track various chemical characteristics of the ocean. When the ocean has white water, the white water is not simply just water with bubbles in it. The white water is actually what oceanographers call sea foam. Also, the salinity of the water is a notable feature of the ocean, and in any point of time we may either be navigating in fresh water or saline water. There may very well be navigational considerations for the salinity of the water. The saline water will be more abrasive, and swimming in it may have adverse health effects. In addition, salt water is not drinkable until it is purified and the salt is removed. It is explained that the maritime navigator will also rehearse the navigational ergonomics of their own ship. It is explained that the sailor's most important and desperate task is to ensure that the ship maintains excellent balance, as losing balance is the most common mode of failure for a ship, and that most capsizing events will incorporate the ship losing balance at some point along the way. So we will account for these balancing mechanics. The ship may lose balance along one of 2 orthotic axes. The ship may have a heel angle which pertains to the ship's balance in the latitudinal orientation. And then we have the trim angle, which pertains to the ship's balance in the longitudinal orientation. The balancing exercise is actually a common navigational exercise, and is compared to standing on a ball. The ship may lose balance along either of these axes. However, it is understood that most vessels have greater trim stability than heel stability, because the length of the ship gives the ship greater angular resistance in the longitudinal orientation. Finally, the examination that I am explaining will involve both the oceanographic studies, where we strived to comprehend what the water was doing, and it will also incorporate the concepts of ship stability. We may hypothesize what types of waves will occur in a stretch of ocean, and then we may anticipate how a ship may react to these attitudes of the ocean's surface, and the results may be embedded either onto a map or they may be embedded into a mixed media article. Therefore, our product would be a customized navigational aid, which aimed to meet the specific needs of our customer. Hypothetically, anyways. Thanks, guys. This has been Machine Pencil Cartography, signing out.